What's up, guys? How you guys doing? My name is Sinalo Jabi, and this is my Quest channel. So I've started a project, obviously, which I'll be upgrading my mathematics and my life sciences. And so I've been like my first 3 videos and my 2 videos, I've been like talking about like exponential functions and dealing with all the parameters. And so today we're gonna be talking about the A and B parameters. So if you're interested not just in mathematics and life sciences right now, because that's the project right now, we'll also be talking about something else. There's gonna be also other cool projects that are gonna be coming in after I'm done with this project, because damn, but it's been a tough project, I'll be honest. Anyway, just make sure, guys, to like the video, click subscribe, and hit the notification button. So let's go. With that said, guys, so I'll now with that said, my introduction said, I'll obviously talk about the effects of this of A and B pretty quick just now. So as if you can see on the screen, so on I'm obviously gonna cut it, put it just here. It's just gonna take a lot of editing, but nonetheless, okay. So guys, so the effects of A and B operate like this. So first, I'm just gonna explain it. If you know what I'm saying, explain how the effects of A and B happen. So now we have to understand. So the step I want to go about this is like this. So I usually want to use steps so that you can get what I'm talking about, if you know what I'm saying. So you have to think about this. So when you have an exponential, so now you're writing an exam and you have an exponential question section, then what you have to have is understand is, okay, I want you to have this thing of okay, I want to draw this graph. So you're given an equation, then what you want to do is to draw that graph, that function on a Cartesian plane. So that's your first thing. So what do we need to draw the graph? So the first thing we'll need is the Q. Okay, look for the Q. You write your value of Q down. That's the first thing. Q, write Q, put it down. Boom. The second thing you will need is your intercept. Okay, now this depend. Intercepts can only be Y, or also sometimes it can be Y and X. So you gotta be careful about that, and I'll talk about when that happens in a little bit. Anyway, and then after you find your intercept, let's say for this instance, which I'm gonna show you there, it's just it's just what do you call this? It's just Y. Let's say our x-intercept is only Y. So when we find our Q, we know our asymptote is there by Q. Okay. The second thing we've done now is that we'll find our intercept. Okay. Let's say our Q is at 1. So this is 0, then 1 our Q. Then after that we have our x-intercept. Again, our x-intercept is probably just like here, our y-intercept. Our y-intercept. So we have our Q, our y-intercept. Now the third thing now you have to know, you have to sort of understand or have or know, is that, okay, I have my Q, I have my y-intercept, but what is my shape of my graph? What is the shape of this graph? That's where these parameters come in, right? Is when you want to identify the shape of the graph. So when we come to the shape of the graph, there's there's 2 questions you have to know, or 2 things or conditions that have to be satisfied. Okay, or questions you have to answer. So the first one is my graph above the x-axis or below the x-axis? That's the first one. Then secondly, is my graph increasing or decreasing? Right? And then that's how you want to go about this. So now I'm gonna explain it using that thing. So now you have to take note that now you have to take note that our A and B come into play when we want to identify the shape of our graph. Okay, shape of our graph, it's 725. Now 725, that's it. 725. So this is 725. I'm just pausing the video quick. And so now what I want to say very quickly is that the values of, so now what I want you to get this, b can never be negative. Okay, in an exponential graph, b can never be 0 or it can never be negative. That's very, very important because it's going to cause trouble when you want to find the intercepts. So now we already know, okay, now b can never be negative. Now let's go. What does a do to your graph? So like I want you to consider these two conditions. First, consider the condition where b is greater, all the values of b greater than 1, our function is increasing. Okay, when b is greater than 1, our function is increasing, and then when b is between 0 and 1 is a fraction, then our function is decreasing. Now this applies to to everything, right? So now, okay, 725. Let's go back to the video, but just know that b does not, our a causes our graph to be either above the x-axis or below the x-axis. That's changing what it means to increase or decrease. So when our graph is increasing on the x-axis or above the x-axis, it goes from like low values of y to bigger values of y. So it has this kind of curve. And when it's decreasing above the x-axis, it goes from bigger values of y to smaller values of y. So it has this curve, right? Now, if our a is negative, remember b can never be negative. If our a is negative, our graph is below our x-axis, and what that means is that increasing and decreasing are different things. Now, for values of b just greater than 1, our function now is decreasing below the x-axis. So it's increasing, so it goes from smaller values it decreases, go from bigger values of y to smaller values of y. So here's this curve like this. And then for values of b just between 0 and 1, our function increases, it goes from smaller values of y to bigger values of y. So here's this kind of graph. So now we know this. So now I'm saying our b, just know this, b only causes our graph to increase and decrease, and that's it. And a causes our graph to either be above the x-axis or below the x-axis. What causes our graph to be below the x-axis is negative values of a only, you feel what I'm saying? The other thing a does is it compresses or scratches our graph, where values of a, when it's above the x-axis, values of a just greater than 1 causes our graph to compress, so it just compresses our graph, and values of a just between 0 and 1, so fractions, causes our graph to scratch. And I talk about how you just have to think about like the trigonometry functions. That's how you can clearly see the stretching and compressing of a function, because you clearly don't see it perfectly when you're using exponential function, but just know that. And then when our function is below the x-axis, values of a bigger or smaller than -1 causes our function to just compress, and values of a between -1 and 0 causes our graph to stretch, but below the x-axis